Hello everybody, this is Nikhil. Today I am going to present my CEO Digital Assignment 3 under Abdul Qadir sir. These are the folders for Nand to tetris. Now we are going to open NOT folder. This is the code for NOT gate. We should load this code and see. This NOT will have one in and one output. Here the input is in and output is out. The parts here are NOT and the inputs are represented in here. This is the comparison file. Now here we are going to run this code in hardware simulator, where we are going to load script and chip. First we are going to load the script, which is NOT script. After loading the NOT script, now we are going to load the NOT chip. Now we have to load a script again. We have to load the NOT script. The scripting is done. Now we are going to run the output. First we will set the values in 0 and 1. The output will be displayed. Now we are going to compare the output with the comparative file. We got the same output, so the output is correct. Now we are going to the NOT file again. Now we are going to compare the output and the comparative file. We are getting the same output. Now we are going to the AND gate. Here the code is displayed. This is the code for NOT AND gate. The parts here are NAND and AND. The combination of NAND and AND. Here the inputs are AB and output is R. The inputs are represented with A and B. The output is represented with out. An AND gate is an AND gate takes two inputs. NAND gate, if the number of outputs are 0, we will get 0. If two ones are there, the output will be 0 if two ones are there. If 1 0 1 1, the values of A and B are considered as use and 1. Use the NAND gate and NOR gate to create the AND gate. So here as shown, the NOT gate is here. NOT gate has one input and one output. Now we are going to run this chip. We are going to load the chip, and next we are going to load the script. And chip is loaded, and now we are going to load the script. So after loading the AND script, we should run the hardware simulator. The output is displayed. Now again we should compare the output displayed with the compared file. The output is same, so the file is correct. So now the compared file is open, and it's correct. Now we are going to the second module. Here we are going to do the full ladder. Now let's open the full ladder file. This is the coding here. Full ladder will compute the 3 bits summation. Here we have 1 bit output. Inputs are ABC and output is sum and carry. The parts here involved are off adder and OR gate. Now we are going to construct the full ladder. The parts involved here are 2 off adders and 1 OR gate. Now we are going to load the script and chips for full ladder in hardware simulator. This chip and script are located in second module. We will load the chip first, script. After loading both the chip and script, now we are going to run the file. After displaying the outputs, we are going to compare it with the comparative file to check whether the output is correct or not. So we got the correct output by. Now we are moving to the next file of for input and outputs of. We use it 16-bit incrementer. Output is in arithmetic addition. Here the input is the 16-bit and the output will also be in 16 bits. All of these are parts, and now we are going to incrementer which adds 1. Now we are going to hardware simulator and load the increment chip. Now we are going to load the increment script, and now we are running the code. After getting the output, we should compare the output got to the compared file to know whether it's correct or not. Both the compared file and output file are same. Now we are moving on to the third module. Here we are going to see about the bit register and program counter. The inputs are low and the parts are the multiplexer and DFF. Which are in short called as MUX and DFF. We have 16-bit register and one. This has to be done one by one. Now we have to create a 16-bit with load and control bits. Now we also have the register. The input is 16-bit, the load is incremental. The parts included are incremental, mux 16-bit, and register 2 mux. Thank you.